Lesson 57 is over least common multiple. There's a way to do this in your calculator, but for the sake of handling the variables, we're going to go over the long way to do it with simple stuff first. That way when we see variables, it is easier. Once we start doing it with variables and numbers, I'll show you how to do the numbers in the calculator. Example 1. So they ask us to find the least common multiple, that's LCM, so get used to that abbreviation, LCM. So let's find the least common multiple of 24 and 36. Okay? So what we're going to do is we're going to find the prime factorization of each of these numbers. So if you wanted to do a tree, if you wanted to do a, however you want to do it, just do it. Okay? Now, after you do whatever method you do, you're going to have to stack them up. So whatever method you do, you're going to have to put it in this order after you're done. So do you guys prefer the chart where we start splitting it like that? Is that how y'all learned it? Yeah? Okay. So let's do that then. We'll do the tree. 24 breaks up into 2 and 12. So 2 is prime, so we're going to circle it. We get 2 and 6 here. Again, 2 is prime. And then 2 and 3 there. Again, 2 is prime and 3 is prime. So after I get all of that stuff, I'm going to write it. I'm going to write it up here just to save room. 24's prime factorization is 2 times 2 times 2 times 3. Okay? Just like when we're finding the greatest common factor, we would list these out. We're going to list them out for this. So here we go on 36. We get, let's say 4 and 9. Then 9 breaks down into 3 and 3, and 4 breaks down into 2 and 2. All of which end up being prime. So 36 is 2 times 2 times 3 times 3. And I only space these out so that my 3's and my 2's line up. Okay? You don't have to do it. I just feel like it's easier for me. So what we're doing is we're going, okay, what presents itself in every single one of these, and then some. So basically I go, okay, there's a 2 here in 24. There's a 2 in 36. Okay, so I'm going to write down a 2. These two match. Okay, I have another set of 2's. Those two match. And then I have this 2 right here. I also need to write that down. I need everything to have basically a match, or if it's by itself, get written down. Okay? So everything that matches gets written down once. Everything that's just by itself gets written down once. So here I have a 3 that matches, so I'm going to write it down. And then I have a 3 right there, so I need to write it down. So basically you're writing everything down, but the matches you do not write twice. Okay? So I have, notice I put these marks here. So I have this, 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 and this. I should have all of these written down. 2, 2, 2, 3, 3. Okay? So then I just multiply that all out. So 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 3 times 3 is 72. So I'm multiplying this whole thing out. I get 72 as my least common multiple. There is another way to do that, and it's just thinking about it, going, okay, what does 24 and 36 have in common, and you do it in your head. But once we get to those variable ones, this way is going to be the way you do it. So let's start practicing. Okay. Let's do another one using the same factorization. This will be for 3 of them. On B, it says, what is the least common multiple of 11, 12, and 18? Okay. You gotta do the prime factorization of these, so if you're going to do the tree, do the trees. I know that 11's already prime, so I'm going to write it down. 11 is prime. Blam. Can't do nothing about that one. I know the prime factorization of 12 because I just did it. It's 2 times 2 times 3. Okay? 2 times 2 times 3. So 2 times 2 times 3. Okay, I don't actually know the prime factorization of 18 off the top of my head. Maybe I'll have to do the chart. So 3 and 6, and then 2 and 3, so it's 2 times 3 times 3. Again, I stack those in that order, okay, for a specific reason. So I start going through these. Okay, obviously 11 is going to be by itself, okay, so I mark it out already. I have this pair of 2's, I'm going to write it down. I have this pair of 3's, I'm going to write them down. Now I have a 2 there that needs to be written down, and a 3 there that needs to be written down. I'm going to multiply all of those together. So the least common multiple of this big number, these set of 3 numbers, is going to be a really big number. It ends up actually being 396. See how big that got really quickly. Now for 3 numbers, I do not have a way to do this in the calculator. I'm sure there is a way, I don't know it though. Okay? So for 3 numbers, you're going to have to do it like this. Anyways, 396 is your least common multiple. Any questions before I move on? Okay, it's going to start in variables, so I need to know for serious. Any questions? All right. They give you a step-by-step in that little chart. I'm going to just jump into example 2 and start showing you those steps. If you feel the need to write them down, you can, but please pay attention while I'm doing the examples. So we're going to find the least common multiple of 10a squared c to the 4th and 15 a to the 3rd c to the 3rd. Okay? I write them like that just so I can start immediately. So the prime factorization of 10 is 2 times 5, and then the prime factorization of a squared is a and a, then c times c times c times c, 4 times. Prime factorization of 15 is 3 and 5, and again I wrote that so that the 5s would be on top of each other. Then I have a times a times a. I'm going to squish those two together really close. And then c 3 times. 1, 2, 3. Okay, I'm going to start looking for the things they have in common. 2 and 3, there's nothing in common with, so I'm just going to write them down. 2 times 3. 5 and 5, they have that in common, so I'm going to put just 1 5 down. A, they have 1 A, 2 A's, and then a straggler along there, so 3 A's. And I have C, 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 3 times. 1, 2, 3. And then our little straggler there. And then I put all this together. 2 times 3 is 6. 6 times 5 is 30. So it's 30. And then A 3 times, which is A to the 3rd, C to the 4th. Now, just like before when we were doing greatest common factor, we took the lowest on greatest common factor. We took the lowest one and we put it on least common multiple. It kind of seems backwards, right? Greatest common factor, we take the smallest. Greatest and smallest go together. Here we have least, and we're going to take the most. So a to the 3rd, notice a to the 3rd is the biggest one. C to the 4th, notice that c to the 4th is the biggest one. Okay, so there's your little shortcut if you want to use it. But 30, a to the 3rd, c to the 4th. Questions before I do another example? Alright. They get hard quickly, so just throwing that out there. Example 3, we're going to find the least common multiple of 3 things. So we have 6 p squared s to the 3rd, 2 m squared s squared. And then we have 8 m to the 3rd p. Okay, again, the shortcut way to do this is just to look at all of them and take the smallest one when you do it. Okay, so I'd go through this and the biggest one. I'd go through this and say, okay, the biggest s I have is s to the 3rd. Okay, the biggest p that I see is p squared, so I'm going to put p squared in there. The biggest m that I see is m to the 3rd. And I didn't miss any variables, I don't think. MPS is all of the variables. Okay? And then I'd find the factor that all of these would have in common. Okay? So, we can do this. 2 and 3 make 6. Just 2 makes that one. And then in this one is 2 times 2 times 2. So, I'm going through here. All 3 of these have a 2 in it. So, 2. Okay. Oh, shoot. Guys, we need to make a correction on example 1. I marked these out and I shouldn't have. I have steered you wrong. You have to have it in common with all 3 to mark them out. Otherwise, you have to write them down each time. So I messed y'all up. Scribble out example 1B because it is not going to be helpful to you. will not be helpful to you. It has to be in all three of the prime factorizations for you to write it down. If it is not in all three, then you have to write it down each individual twice. So like on this one, I would have had to write down 2 times 2, and then 3 times 3. I would have had to write that one down again. So this number here would have actually ended up being multiplied by 2 again and 3 again, because I messed up. Okay, so we have all these straight down. 2 gets written down one time because they have it all in common. Now here I have a 3 that's not in common with anything else. I have a 2 that's not in common, and another 2 that's not in common. So I write down the 2, the 3, and the other 2 2's. I'm so sorry about that. Okay, and then I would multiply all those together to get my final one. But here I'm going to finish writing out this one long way, so it's P times P and S, S, S. And here we have M and M, and then S squared, which is S and S. We have M to the third, M, 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 and P. I'm going to go back to my example. Sorry, I backed up. Okay. Oh, shoot, guys. Example 4 starts with remembering what polynomials stand for, okay? Polynomial, poly means many, nomial means terms, okay? So it wants us to find the least common multiple of these two numbers, 3x plus 1 and 2x plus 9. Now the question is, what is the least common multiple of those? Okay, I want you to think about factoring this out. Is there anything that we can factor out of 3 and 1? No, there's nothing we can factor out of it. So this is prime, for lack of a better word. 3x plus 1 is prime, because there's nothing we can factor out of it. What about 2x plus 9? That's also prime. We can't factor out a 2 or anything out of the 9, right? So these are both already in their prime form. So what if I had told you, okay, so let's look at 2 and 3. What is the least common multiple of 2 and 3? 6. How did you know that? You said 2 times 3, right? You multiply them together. So when I have two things that are already in their primal form, I just multiply them together, typically is what I do, right? So look, these two things are in their prime form. We're going to multiply them together. So now there's something that y'all just don't know. It's called FOIL. Write it in big letters straight down your page. And when I say big letters, I just mean capitals. FOIL, F-O-I-L. Okay? It's really simple. First, outside, inside, last. Okay? It's a way to multiply binomials. That's what these are called. They're called binomials because there are two terms in them. They're called binomials. So what I'll do is I'll set these side by side. So 3x plus 1 in parentheses, right? Multiplied by 2x plus 9. So now they're side by side. So what I'm going to do is I'm going to multiply these out, and basically it's distribution. Okay? In reality, this is what I'm doing. I'm taking 3x and I'm going to give it to 2x plus 9. Okay? And I'm going to, because it's addition, I'm going to add that to 1, which is going to be given to, again, 2x plus 9. So in reality, I'm distributing these pieces. But let me show you what FOIL means. First times the first, this is the two firsts. Okay? So first times the first is the first. So it's 6x squared. X times x is x squared. Okay? And then it says the outside. So this is an outside and 9 is an outside. So because that's going to end up being positive, it's 27x. 3 times 9 is 27, and the x is there still. So it's distributing this 3x to each of those things. And look, the way I wrote it here, we would still be doing the same thing. So I would get the same exact answer, 6x squared plus 27. Okay? So that would be this distributed. Now, I'm going to take the 1, and this is what I do so I don't lose track. I go underneath on this one. Instead of writing my distribution arrows on top, I'm going to write them underneath. So 1 times 2x is 2x. Positive 2x, I might add. So I get plus 2x. And then I got to distribute my 1 to the 9, so I get plus 9. And again, if I would have done that on this one, I'd get the same numbers. Okay, and then I combine like terms. My like terms are the things that are in the middle. The O and the I always get combined because they are always the same. Lastly, okay, I can't think of a single binomial where they weren't, at least in my examples. Okay, so 27 and 2 make 29 because they're both positive. They have the last name X, so I'm going to leave it that way. And I'm just dragging the rest of this stuff down. 6x squared plus 29x. And this is my final answer right there. We actually had to multiply them. So I'm showing you how to multiply these because we're going to do that in a later lesson. So they tell you your least common multiple is this multiplied by that, which is true, and that's what this answer is. So on B, let's go on to B. Find the least common multiple of 7x squared plus 21x. Okay, we're going to see if there's anything we can factor out of that thing. And then it also gives us second number 6x plus 18. And we're going to see if there's anything we can factor out of that. So, here we go. What can I factor out of 7 and 21? 7. I know where your mind was headed. Okay, what about the x's? I have an x squared and an x. What can I factor out of that? 1x, right? So now I have 7x being multiplied by what is inside what is left, right? So if I pull a 7 out of this, I'm left with 1. If I pull an x out of this, I'm left with 1x. So here we go. There's my x. If I pull 7 out of that, I'm left with 3. If I pull an x out of it, there's no more x's left, so I have x plus 3. So I factored this out. So basically, this is my prime factorization, for lack of a better way to write that. This is my prime factorization, because I can't pull anything else out of x and 3. What about this guy? What can I pull out of 6 and 18? 6. Can I pull out an x out of anything? No, because it's not in both terms, right? So if I pull a 6 out of a 6, I'm left with a 1. 1 and x make 1x. If I pull a 6 out of the 18, I get a 3. Okay, and then I'm going to do the same thing that I did before. I'm going to go x plus 3. Those are in common, so I write it down once. I have a 7x, which is basically a straggler, and I have a 6, which is basically a straggler. Okay, so I'm going to write both of those down. And then I just multiply them all out. So my least common multiple is this thing. I'm going to go ahead and multiply it. 7x and 6x make 42x. And then I have x plus 3 that I need to go ahead and distribute. So when I distribute this, I go 42x squared. And then I distribute that one, and I get 126, I think, x. Right? So that would be my least common multiple. You can do the same thing for part C.